So as usually, a quick note about our releases. So we are not changing the release cadence. We still plan to have 4 releases per year. And so this is our 3rd release this year. And the next one will be in December, just before the holidays. To have a look at what's interesting in 6.2, we have a few highlight features that are the interesting ones. So the first thing that we implemented in this release is a significant extension of the capabilities of data catalog and Wrangler, and that's the ability to write to essentially any data target in your Wrangler, not just Excel files or CSVs, but you can build custom targets just like you can build sources. With that, we have introduced interactive visual mapping in Wrangler so that you can very easily map from whatever structure you are working with to what your data target requires. And this also allowed us to implement new functionality that allows business users and IT to collaborate more closely. In essence, business users can create business logic for in Wrangler, and that can be very easily imported into your designer project and included in a larger process or larger framework. As always, we've implemented new steps in Wrangler, this time focusing on validation and data transformation steps. And we also extended our libraries to support what we call a health check, which allows library designer to build a job that verifies the status of the library, and you can then easily monitor that so that you can see whether your connectors are working properly or not. We also started working on Java 17, so CloverDX, since this release, supports Java 17, and you can deploy Clover with Adoptium JDK 17 so that you'll use newer stack. First, let's talk about data targets. This is the biggest feature we've implemented so far in this release. And as I mentioned before, this is something that allows you to publish your data targets in data catalog, and data targets allow you to write into anything. So just like you can build a data source that reads from anywhere, whether that's an API, database, or something else, you can create a data target that can again write into APIs, databases, files, or anything you need. As data sources, targets are listed in your data catalog, so you can very easily find them. I'll show you in a couple minutes what it looks like so that you'll see how the filtering works and what information is available for each target. You can very easily filter. For example, in here we can see one of the targets. This is a snowflake target, and this is a source. You can easily distinguish between them based on the label that we've added there. As for sources, targets carry all kinds of metadata with them. So for example, you can get information about or the basic description of the target in here, or if the target requires some specific data layout, you'll be able to see it in the catalog as well. Just like data sources, targets are implemented as subgraphs, which allows you to implement any functionality within them. So far, what we've seen our customers work on are targets that implement custom validation, various post-processing or enrichment of data that's being sent to the target, additional reporting logic, or all kinds of other things. Essentially, anything you can create in Clover can be included in the target. As with data sources, we will be publishing new sources and targets in our CloverDX marketplace. I'll talk about what's new there in a couple minutes. The targets brought quite a lot of new functionality to Wrangler. One of the new things that you can do is what we call visual data mapping in Wrangler. It's essentially a way for business users to map data from the layout that they have in Wrangler, so what you see in your data preview, to what the target requires. There's a new mapping mode that you can switch to in Wrangler. I'll show you what it works, what it looks like and how it works a little bit later during the demo. But in essence, it allows you to very easily drag and drop your columns from your data to the target columns, and you can easily see the status, whether it's correct or whether you have any mapping errors. And this is something that allows you to very easily change layout of your data from what you have, what you're working with, to what your target requires before the data is written to the output. As with everything else with Wrangler, this is fully interactive. There's no coding involved. So as you are drag and dropping your fields, you'll see the status right away, whether your columns are mapped mapped properly, whether there are some data type conversion issues and so on. We also have auto mapping functionality that can help you with larger mappings. It will try to figure out the mapping automatically based on types and column names. So if you have, for example, 50, 60 column to map, it can easily hit most of them automatically, so you don't have to drag and drop so many fields by hand. Together, the mapping and the targets allows us to implement much better way of business users and IT to collaborate. Essentially, what you can do is that you can create your business logic in Wrangler, just like any other Wrangler job. You can then export that and then import it into a designer job. You can see parts of the process on the screenshots below. You go from a Wrangler job in here to a subgraph that you can call from any job in Clover, whether it's a graph like we see on the screenshot in here, subgraph or job flow, or anything else. And this is something that allows the IT to create frameworks that allow you to, for example, ingest large data volumes or work with files in more complex manner than what's possible via Wrangler, but still get input into how the mapping is actually done from the business. Typically, the domain experts or business users know how the mapping should work. And instead of writing the specification in Excel file, Word document, or something like that, they can build it in Wrangler and deliver to the IT to integrate into the final solution. This is all supported throughout the platform. So, of course, if you create a job like this in Designer, you can then automate it on the server, for example, through scheduling, even listeners, or even call it as an API. We implemented new Wrangler steps in CloverDX 6.2. We have 5 new validation steps. So this will help you make sure that the data that you are processing in Wrangler is valid. You can see the list of steps in here. They are relatively basic, so they allow you to verify the basic properties of your rows in Wrangler. For example, whether your columns are empty, whether values are in range, whether they match patterns, and so on. You were able to do these kind of things even before, but you had to write formulas. Now there's a simple solution that allows you to just select a step from the list of available steps and apply it to a column without having to write anything. We've also implemented one new transformation step called split columns. It allows you to split one column into multiple columns based on a delimiter. A common use case is, for example, extracting phone numbers. Right? Oftentimes, we see in our data a phone number or phone numbers column where people write multiple numbers into it. And with split columns, you can very easily split it into separate columns, one per phone number based on the delimiter, whether it's a comma or anything else between the numbers in there. At the same time, we worked on improving the user experience for writing formulas, because while Wrangler is essentially a no-code tool, you can still need to write formulas in some cases, like for example in here where we are calculating the difference between when the invoice was paid and today, and our new formula editor is much more powerful. The syntax highlighting is much better than it was before. It validates your formula real time, so you'll see underlines in cases where you made a syntax error, and it has a content assist. So when you type $, or press Control Space, it will show you a pop-up like this where you can pick from the columns that are available in your data set. So this is much easier to work with than having to essentially copy the columns from the headers in your preview. Makes editing the formulas much faster. Another feature that we implemented is called Library Health Check. This is something that allows the library authors to provide far more information about the library to the administrator of the system where the library will be deployed. Before CloverDX 6.2, you basically didn't have any information about whether the library was okay or not. And typically, or very often, the libraries are implementing all kinds of connectors, whether they are data sources, data targets, or even connectors that are used in Designer. So not Wrangler connectors, but other readers, writers, and so on. And these need to work with external systems like APIs or databases. And the health check jobs in libraries allow you to implement just that kind of health checker. And so your job can connect or can try to connect to whatever source or target the library works with, verify the connection properties, and depending on its return status, the server can track that. And if the status is invalid or it fails, it will mark the library as failing. You will be able to see that then in, for example, operations dashboard. In here, you can see a screenshot of a system where there are 4 connectors, one to Snowflake, Clockify, ClickUp, Northwind, and you can see that one of them has failed. So it's very easy to spot a library that's failing. And as usually, when you click on this in the dashboard, you'll get full details of what's the problem with your library, and you can try to resolve that. For example, updating the password if it's expired or something else. This is all using the already built-in functionality into the server. So it uses the standard scheduler, so you can schedule your health check to happen as frequently as you want, whether it's something that's not so critical, so you check once per day, or for a critical system, you can check even every minute or so, depending on what you need. As I mentioned at the beginning, we've been working on updating the platforms on which Clover can run. Java 11 is slowly getting to a point where it will stop being supported by the vendors. Currently, the deadline is October next year. So in CloverDX 6.2, we added support for deployment on Java 17 for the Apache Tomcat stack. For VMware and head-to-head, you can't use Java 17 now, but with Apache Tomcat, you can. So you have the option of either running with JDK 11, like you could before, or deploying on Java 17. There are several benefits of running on Java 17. For example, we've observed better performance with Java 17 without any changes in your graphs or anything else. We've seen 5 to 20% increase in performance depending on the use case, especially in the cases where your jobs work with a lot of memory, often like many string operations and so on. Java 17 has a faster garbage collector, so it shows in the overall performance of the platform. One of the things that Java 17 also allows us to do is to enable job queue in Docker. In Java 11, reported performance numbers incorrectly in Docker, which meant that job queue couldn't be enabled. But now it can. In Java 17, it reports those numbers properly. So you can enable job queue, which will increase the stability of the instance. When job queue prevents the instance from being overloaded, so it's much better to have it enabled. This is also the reason why Docker deployment is the only one which uses Java 17 by default. Other deployments, when you look at that, at how they are configured, they use Java 11 by default. And if you need to, you can enable or switch to Java 17 in the configuration. And of course, Java 17 is a long-term stable or long-term supported release. So for now, the end of support is in October 2027, which gives us quite a bit of time to move to next Java version. And as I mentioned, Java 11 seems to be supported only for next year. It's quite possible that it will be extended, but we can't count on it. I mentioned at the beginning that as we implemented data targets, we also added new libraries into our marketplace. One of them is Snowflake Data Target. This is essentially a wrapper for our Snowflake bulk writer component that allows you to write to Snowflake directly from Wrangler job. So anything you can create in Wrangler as your data set, you will be able to write to Snowflake. We also implemented Google BigQuery, which is similar to the Snowflake. Again, allows you to write to BigQuery from Wrangler, but its primary usage is for high performance data loads directly from Designer. There's a lot of options in the component that allow you to fine tune how it works with data, and it uses the high performance streaming API, so you can load massive data volumes into BigQuery very quickly. Both of the libraries are available in the marketplace for free, so you can download them. You can even look inside to see how they are implemented as an inspiration if you need to do something similar. And as always, we implemented quite a lot of smaller changes. One of them is, for example, we upgraded the Snowflake driver. The newer driver fixes all kinds of smaller issues within Snowflake, so it's always best to keep those drivers updated. There were also some security fixes within the driver and so on. And it also allows you to use newer and simpler JDBC URLs, so you no longer have to compose the URL that's as long as it was before, but it's much easier to do that now. But in general, your jobs that you've built in previous versions of Clover will be working just fine, even with newer Snowflake driver. You do not have to change anything there. We implemented few convenience features that will allow you to support your systems better. It's now much easier to download support packages and logs, especially if you are working with more complex environments. For clusters, you can now download the support package from all cluster nodes at once. Before, you had to log into each cluster node separately, download the package, collate them somewhere, and for example, send it to our support team if you are working on something. Right now, there's a button that does all of that for you, so makes the process much simpler and much faster. And similarly for logs, oftentimes when looking into production issues, you need to investigate more complex job hierarchies. So now there's a simple button for downloading the complete execution tree with a single click. You don't have to download log from each job separately, save it somewhere in a folder and zip it, but you just push the button and does that for you. To allow you to automate these tasks, we implemented a few new APIs. There are 2 new APIs that allow you to download the support package automatically. One of them is for single server downloads, and the other one is for downloading the support package from all cluster nodes, like in here. And we also implemented a new abort job API that allows you to stop the job. So far, you had to use simple HTTP API, but now we have a newer API for that through REST API. As always, there are also some changes that require you to, or that might require you to look into your jobs to see whether they need to be redesigned. The biggest change in here is the change in Samba or SMB access. We have upgraded the library that provides that, and the new library is much stricter in what it allows. The SMB, according to specification, doesn't allow anonymous access, even though many Samba servers are configured to allow it in some way. So the library doesn't allow that anymore, which means that if you are connecting to Samba from CloverDX, you should have a look whether you are using anonymous access or not. And if yes, you'll have to change that. You'll have to reconfigure the SMB server to, for example, create a guest user without a password as a workaround, or switch to a proper non-anonymous account so that you log in with username and password to your Samba location. And the second smaller compatibility change is that we now disallow sandboxes with reserved names or locations. So you can no longer create a sandbox that's called libraries or sandboxes home and so on. There are a few of these names used by the system, and we no longer allow them to be used in your custom sandboxes, because even though it worked previously, it was very confusing, and many users, when they created sandboxes like that, by mistake couldn't find them because they changed location based on what name you picked. So that's as far as the slides go. Of course, I'd like to show you the demo of the new features. So just give me a second to switch, and I'll start with the catalog, right? And I'll show you how the targets work and where they are in the catalog. So as I mentioned at the beginning, we've added the ability to have not just the data sources in your data catalog, but also data targets. They can be easily spotted by having a separate tag. My targets are blue, sources are green. So we are keeping with the color scheme we introduced in the designer many years ago. And you can very quickly filter them. Just click the targets, and you will be able to see all the targets that you have there. As I mentioned, you can see more details about each target. For example, the Snowflake one is a very simple target, doesn't require any specific data structure. Whatever you feed to it, it will process, and it will attempt to write it to the table that you designated, which obviously can either work or not, depending on whether you match the structure. And just as with anything else in data catalog, you can add it to your targets in this case. So it added to a list of targets that you have already configured. When I do that with Snowflake, I can see all the settings that the target has. I can specify the name of the table to write to, whether to continue an errors or not, whether to create a new table if it doesn't exist. And of course, there are settings for the Snowflake connection itself. And so this is the configuration that you can have. And of course, you can then use the target in a job. So let me open a job that does just that. I have a simple job that reads from a data source called online store products and loads it into Snowflake. So let's look at what that looks like. We are keeping the same structure of the job, right? So you have the source where you pick the source location. You can then implement your transformation. In here, I'm not doing anything complicated. I'm simply deleting a single column from my data, and then I'm writing to a target. So this is how you can see where it writes, the configuration of that. You can edit that if you, for example, wanted to change the name of the table and so on. And there are a few new things about running the jobs when you have custom data targets like this. You can obviously run the job just like before. When I click run, it will read the data from source, apply the transformation, and write everything to target. But since writing to target can be potentially destructive operation, right? You can write to all kinds of systems on the output, and we don't know what they do. We also introduce the ability to run a test. When you push test run, this is a safe operation. You can do it as many times as you want because target is essentially disabled. So it will run the whole transformation and so on, but it will not write anything into the final destination. So in here, for example, you can see that the Snowflake part was disabled. Right? It tried to write almost 7,000 records, but they didn't go anywhere because they were skipped. But all the validation and everything else, the transformation has processed. If it failed, I would be able to correct, or if the data didn't look the way I wanted it to, I would of course be able to look at it as well. Once you are happy and your test runs produce the results that you expect, you can run the job. And this is when it starts being interesting, because this is now going to write to my Snowflake table. So it's reading the data, applying the transformation in the middle, and then writing in the end. And you can see that this is no longer disabled. We can even look into our Snowflake instance, right? So this is the table that I wrote to, and I have 7,000 records in it, right? Well, almost. This is exactly the count that I wrote in here. You can see it's the same. Oh, sorry, it's the same number. Right. So this is how you work with targets on a simple level. You simply build your transformation or Wrangler job just like you did before, but instead of selecting just an Excel or CSV target, you now can select from any target that you have available in your data catalog. Where it gets a bit more interesting is when you have a data target that requires some sort of data structure. Oftentimes when you write to a target system, you can't write just anything, right? It might require some specific columns, for example, an ID or a name or anything else. And I have a target like that in here called order payment target, which requires this kind of data structure, right? So it has 6 columns. 3 of them are mandatory, the ones with the star in them, like order ID, the amount, and date. Those are the minimum that I need to provide for the payment to be valid. Everything else is optional because it does have some sort of default value. When you use this kind of target, you can do it just the same way like you did before, either adding it to my target or using it in a new job directly. So let me open a new job that works with that. I'll open this one. Oh, sorry. This is what I wanted. So it looks just like before, except you can see that there is a new element in the steps list on the right side, and the header looks a little bit different. There's a new entry called mapping, which allows you to go from whatever structure you have in here. So whatever you arrive at in the last step before the mapping takes and maps to the structure that the target requires. And the columns that are used in that mapping are signified with a little linking here. If you click on that, you go to the mapping and it will highlight the column, or you can edit the mapping directly by clicking on it. And you can see that the screen changes a little bit when I do this. This is called the mapping mode, where we can use drag and drop to map our data. Let me clear everything to see what it looks like. So this is what it looks like when I start with an empty mapping, right? Nothing has been mapped, and the columns that are required are highlighted in red. You can hover over the arrows in the middle in here, and it will tell you what the problem is. In this case, the column is not mapped, but of course it can be also something different. For example, if I try to map a date column into an integer, it will tell me that the data types do not match. You can, of course, unmap and so on. Right? So you use drag and drop to map your columns from what you have in your data set to what you need in your data target. So let's have a look. For example, order ID. This is something that I have in here. I can do amounts, others here, and so on. As I mentioned before, we actually have the ability to map columns automatically. So there's a functionality called automap. When you press that, it will try to match column names and types in the whole data set and the target, and will map the ones that match together. So if I press this, it was able to fit everything except the payment type, because there's no column that's called payment type, and there are two of them called type. And so which one to map? And this is actually the one we want, right? One of them is a string, so this is the column that we need. I can drag it up in here, which now completes the mapping, right? All columns are mapped. I don't see any errors in here. If there were any problems in the mapping, I would see them in here. So my mapping is now complete, and I can run it. Just as before, this is a data target, so I have both options, whether to run it directly to write to the target or do the test run. They work in the same way, right? You can think of the mapping as a separate step that just performs the final step of the transformation, so that you don't have to create multiple steps to rename columns, reorder them, or anything like that. It allows you to do this in a single step in a comfortable interface with drag and drop. You can, of course, map single source column into multiple target columns as you need. If there is an error within a column, you will also see it in here. In the little link will be changed and it will be red so that it will show you the status. So let's try running this to see what happens. Right, and in this case, it will, it's actually reading file. About 8,000 records read, 24 were rejected. And an interesting thing about targets is that the data target can reject data on its own, right? So some data can be rejected, for example, as data errors in the Wrangler job, but the target itself can reject data. I think this one does that. And you can see this where 55 values were invalid in the target itself. And the target can implement any validation that you need. And as I mentioned before, anything that you can do in Clover, you can do in a data target. The interesting part comes when you think about how you can use those targets. In here, I have the two jobs that both have similar names. You can see them in here. Let me sort like this. So we have order payments client A and order payments client B. And this is to support a use case where I'm essentially doing data ingestion. Like I mentioned, this is a way for domain experts to build their mapping or the transformation from whatever the client provides into the format that they need, into an internal format, and then give that to the IT team. And that's very simple. You can export your job, right? Just click on an export, finish this, and it will give you a zip file. Then you can send to your IT any way you want, like an email, Teams, or save it into a shared directory or something, whatever works for you. And then when the IT needs to use that, they can switch into a designer. And let's say that they already have built their framework, right? So they have a process like this that reads files from a directory. So we have the files arriving into two directories. Client A uploads their files in here, client B uploads to here. And when I run them, I want to figure out which job to run, right? Either client A or client B, because they are different, and load the data into my target. In my case, I'm writing to Snowflake, and the framework is able to figure that for me. And the interesting part happens in here. When I go into process payment file, this is a graph just like any other, and this part comes from Wrangler. What I did was simply drop one of the subgraphs in here and then change the URL to be a parameter, which I can feed from the parent job flow. And this allows me to dynamically change essentially the Wrangler job that runs when I'm processing my files. You don't have to do dynamic selection at all. You simply can use your exported Wrangler job that I have in here, right? I imported my two jobs, client A and client B, in here, and they are normal subgraphs that you can feed your data into. They also publish metadata, so you can very easily see what kind of metadata they have on output and also what they have on input. Right? So in this way, you can very easily build different processes with transformations from Wrangler, but wrapped in a more complex process built in Designer. Of course, Designer has far more functionality than the Wrangler, and you can work with files in more work with your data in more complex ways. You can send notifications directly from here, call an API directly, and so on. So it's up to you how you do this, but it allows you to connect both parts together, what your domain experts are doing in Wrangler and what your IT team is doing by basically building a platform for them to run. Let's see how it runs. Oh, okay, nice. So let's run the parent job flow. And as I mentioned, this is a very simple one where it just scans the directories in here. It finds a number of files, lists only the files that we want, and then it finds the job to use as a mapping for based on the name. And it's a simple name match. Whether it's client A, it uses the client A job. If it's client B, it uses client B. And you can see as the jobs are running over here, right, they keep appearing in here. We have 6 files, so they are all done now. And we can look at the statistics over here. We processed 6 files, different sizes, no rejected records on input, so the files are valid. Some records were rejected by the mapping itself, and there's a data conversion errors and so on in Wrangler. And this is how many records were left out and written. And obviously we do get runtime statistics from the Designer itself. Everything finished okay. And just as before, we can have a look into Snowflake. This is where I'm writing my data to see what rejected records look like, or even what my transformed data looks like. And so in this way, you can very easily connect both business side and the IT side, and their interface is essentially what your data target provides. Right? So you can build your data targets and then export the jobs that map into those and import them back into Designer and run them as part of a larger job flow, for example, just like I'm doing in here. Another feature that I mentioned connected to libraries is the health check job. This is something that you can see right in a library configuration. So when you install a library from a repository or even dropping the library manually, you will have new options in here. When a library contains health check, there's a button to schedule health check. Once it's there, you will see its status in here. For example, my Snowflake library, the health check is okay, but the Clockify one is not. Right? I broke the configuration on purpose. And let it run, and it will tell me what the problem is. Right? I can click on that to see where it fails and so on. I get the error details. Right? In this case, I simply broke the configuration, so the error is not very nice. But in many cases, you'll be able to see, for example, that it couldn't connect to an API and so on. And what's interesting about health check jobs is that they are just regular jobs, so they can do anything you need. For example, for Snowflake, actually, let me run it so that I can find it easily. For Snowflake, oftentimes you want to see what kind of Snowflake you're running against, right? So that you know that the configuration is valid. And this is exactly what I can see in here. The health check job, you can see this is its execution, provides output to me, right? What's the client version, name of the database, and so on. So these are all tools for the support team to see more about how their system is running, and when something is a problem, for example, when the health check comes back with an error like object doesn't exist, sometimes it doesn't tell you what object it is, but you can typically sit in here in this kind of status so that you can very quickly debug the issue. And as I mentioned before, the dashboard allows you to build your dashboards in a way that allows you to quickly see whether your libraries are working properly or not. I have 2 dashboards defined. One of them is just for connectors, where I have 4 monitors, 1 per connector. With Clockify, I can see what happened in here. Or I can do it in a simpler way, where I have a dashboard that monitors the whole system. So I have a single monitor for all my connectors, and I can see all them here. 3 are fine, one of them is broken, and the other stuff runs just fine.